Yeah, I have to get rid of these things. I think it will not matter. I think, yeah, okay. This comes here. Right, so this is midterm 2, last year's exam. You have to be quiet, right? I'm the one talking here. So, question number 1. Which of the following statements is not true? You see that this is being. Why am I? Okay. Not true. So that is, usually pick the one that is true, right? So here pick the one that is not true. So always you have to read the question carefully. So this means only one which is not true. Let's look at this. Force is a push or pull, it is true. So I cannot choose it because we have to choose. B, force is either a contact force or non-contact force. This is one of the way of classifying it. So it is also cannot go into not true. C, force is a vector. That's also true. So he is also out having both. D, force acts on a material object. Yeah, it has to be something material, right? It doesn't act on words or something. So that is also true. So you cannot pick it. So E says force can acting on an object. A force can be acting on an object A without A exerting any force on another object. Yeah, there should be always, suppose an object experiences a force, that means somebody is putting a force. So he's not, it's Newton's third law, right? He's not going to stay put. He will say, oh, you are pushing me, I will push you. So there will be another force. So this is incorrect statement. So that is why we pick it, because it's asking for the incorrect statement. So let's go to question number 2. A box is pushed with a force of magnitude F on a smooth frictionless horizontal table, with the box is sitting on a smooth frictionless horizontal table, and you're pushing it. Which of the following statement is true? This time only one is true, the rest are all wrong. So the highlighted one is the correct answer. So let's start from the one from the bottom and go up. So you're asking about this particular force F given by the finger, the person pushing it, on the box. So E says Newton's third law, so this again, does not apply as the box is moving. So it's not true. Newton's third law has nothing to do with whether the object is moving or not. It only says if there is a force, there will be another force, reaction force, but they are not on the same thing. It will be, yeah, it's not the same object. One is on object 1, other one is on the object 2. And another thing is, those two forces acting on two different objects, they will be having the same magnitude but opposite in direction. That is Newton's third law. So this statement is wrong. It is always happening. Newton's third law, whether the object is moving or not, it doesn't matter. Even if it is moving, it is working. Even if it's not moving, it's also happening. So this is wrong. D, according to Newton's third law, the box should not move. No, it's not like that. This is one of the wrong idea you have. You say, oh, one force is to the right, other force is to the left. They are equal in magnitude. They should cancel. What you are getting wrong here is one force is on the finger, the other force is on the box. For the box, there is a net force. You cannot say, okay, there is a force F on this, and there is a negative force on F on the box. No, it is not on the box. It is on the person, on the hand, right? So this is no. Again, this is the force on the box, and there is another force on the finger. These two forces are not acting on the box. One force is acting on the finger, the other force is acting on the box. So if you take the box, there is a net force on the box. It is there. No, there is no cancelling of the force. Okay, so that's one of the most confusing thing about the Newton's third law. When you don't understand it properly, you make that mistake. You say, oh, there are two equal and opposite forces, the net force has to be zero. No, the net force on the box is not zero. This force is on the box, the other force is on the finger, right? So he is also wrong. C. According to Newton's third law, the box exerts a force of the same magnitude F on the earth. No, you are missing the object. The object number 2 is the finger. So the force F in the opposite direction is on the finger, not on the earth. So that is also wrong. B. According to Newton's third law, box exerts a force of the same magnitude F on the table. Again, the object is wrong. So this is the right one. So the opposite force, because the interaction is from the finger on the finger is pushing the box to the right, so the box will be pushing the finger to the left. So this is correct. Okay. So now if you have understood this, you have perfectly understood Newton's third law. Good. So let's go to the next one. I figured out how to, use this pen on this. Now it is not appearing here. So I will post it, okay? It's a recording. So, right, question number 3. There is a person, if I am the person, my weight is this when I am on the earth. And gravitational acceleration on the earth is this. And if I go to another planet, a very high gravitational acceleration, so my weight has become in that planet, let me call it X planet. It has increased a lot. And with this information, can I find the gravitational acceleration on that planet? Gx. Okay, so if you go to another planet, the gravitational weight, the weight will be mass, it will be changed because it is not Ge, it will be Gx. Can I find the Gx? I have this, but I don't have this.
Wait, I have the second one.
Yeah, I want to find this, right? This is the question. So I can substitute for this. What about the mass? I don't have the mass.
From the Earth. No, the mass is the first. Don't change.
Yeah, mass doesn't change. So what do you do?
I put the first number.
No. This is the weight. Yeah. This is this. We know this and this. So I can use this to find the mass from the Earth data.
Yeah.
You got it? Yeah. Okay. Don't, just go and put that in because that is in Newton, right? Not in kilogram. So I need the mass. So use this to find the mass. So it will be equal to 741 divided by 9.8. Somebody calculate and tell me what it is. Then I can bring that value and put it in here. This equation gives me what I want, Gx. Gx is equal to Wx divided by m. Now I have the Wx and I have the m from here. 75. Yeah, first tell me this. How much is this? The mass?
It's 75.6.
Okay, 75.6 kilogram. Right? Then you bring it and put it in here. So that will be what? Wx is 5320 divided by 75.6. You should get 70.4. Could you check, please? Okay. All right, let's go to the next question. Number 4. A crate is sliding down an inclined ramp at a constant velocity of 1.5 meter per second. The vector sum of all the forces acting on this crate must point. He's asking for the net force. You know what we mean by vector sum of all the forces mean? He's asking for the net sigma of the force. So, can I answer this question?
0.
Why?
Because the acceleration is 0. Constant velocity.
Okay. Did you hear that?
No.
Velocity is constant. Constant velocity mean acceleration is 0. Acceleration 0 mean then you can apply the Newton's second law. What is Newton's second law? If this is 0, this must be 0. M is not 0, right? There's a mass. So that means net force must be 0. So this questions. So the net force is 0. Now he is saying what is the direction of the net force? If something is 0, can you even talk about the direction? No. So that means this is wrong because it's 0 acceleration. It doesn't matter what direction you are giving. All of them are wrong. Because when the net force is 0, can you talk about its direction? No. So this is the only correct answer. None of the answers are correct. So if you want the correct answer to be written there, you say acceleration is 0.
Is this the last midterm?
Yes, last year's midterm. So let's go to the next. Question number 5. A constant force of 160 Newton is applied to an 86 kilogram crate on a rough level surface at an angle of theta equal to 24 degrees above the horizontal as shown in the figure and pulled along the surface. Which of the following statement is true regarding the normal force N acting on the crate? Okay, right. So how do I answer this question? We are asked about the normal force. So we need to get an expression for the normal force. We don't need the value because the answers are comparing. Okay, so anyway, what we do, we apply the Newton's second law. What is Newton's second law? Net force is equal to mass into acceleration. So here we want an expression for the normal force. Normal force is in the y direction. So naturally, you will just only focus on the y direction equation. The net force in the y direction is equal to mass multiplied by acceleration in the y direction. So we have many forces, right? Normal force, applied force, gravitational force, friction force. So this is not going to come in the picture because it is horizontal in the x direction, so nothing, it will not contribute. N is there, so N, it is in the positive y direction, and F has a component of F sine theta in the y direction. We'll substitute at the end, okay? So plus F sine theta. What about mg? Mg is in the negative y direction, so I covered the left hand side. Equal to right hand side, m is m. What is the acceleration in the y direction? It is moving only in the x direction. Is the y coordinate changing? No. So what is the velocity in the y direction? 0. Is it changing? No, in the y direction. So it is not changing in the y direction. That means acceleration is 0. Okay. Anything multiplied by 0 is 0. So that will give me n plus f sine theta minus mg equal to 0. That will give me n equal to mg minus f sine theta. Okay. So here all of these are magnitude of the force, magnitude of the mass, and magnitude of the g. And so n, this is a negative number, right? F sine theta is a positive. There is a negative in front. So you are subtracting from mg some value to get the normal force. That means n is always less than mg. Okay, n is mg minus some value. So that means n is less than mg.
تساوي ام جي ليش؟ يعني تخيل قاعد تطبخ رقم سالب ولا زالت كم تساوي؟ لا الام جي دائما تصير ارقام فانت قاعد تطلع رقم سالب وقاعد تساوي ان وتقارن رقم سالب.
See, when you pull something from the box, if you pull like this, n will be mg, right? Because theta is equal to 0. Sine 0 is 0. But if you pull like this, you are lifting it is not getting lifted, but you are kind of pulling it up. So it will be touching the floor less. So the n will be less than its weight. Okay, got it? If you pull horizontally, n will be equal to mg. Sine theta is 0. But if you pull like this and it is moving like that, it will be touching the flow a little bit less. So the pressure or the force that it is exerting on the flow will be less. That means the n will be less. So, but you are proving it with the equation. Okay.
So that's why we don't put E.
N is never 0.
No, E.
E. Yeah. It is not correct because n is equal to mg minus f sine theta. But if theta is 0, suppose you pull like this instead of pulling like that. Okay, tell me what will happen if I push like this. Yeah, n will be mg plus f sine theta at the end. So if you pull something like this, actually you are pressing the box more on the floor. Obviously the n going to be greater than the weight itself, right? Okay. But that's not what we do in this question. Number 6. A person who normally weighs 700 Newton is riding in an elevator that is moving upward but slowing down at a steady rate. If this person is standing on a bathroom scale inside the elevator, what would the scale read? If you have the box, okay, and this is the N, and this is the mg, and if the box is its elevator is not moving, for example, then you can say net force is equal to mass into acceleration, but the acceleration is 0. Then you will get n minus mg equal to 0, n is equal to mg. But this is not the case when you are not generally the case because the elevator can move. So acceleration is in general not equal to 0. So that means the correct equation in an elevator is going to be n minus mg, that is the net force, is equal to ma. I cannot say this is 0 now in general. So our equation becomes n is equal to mg plus ma. So you can kind of remember this like the elevator equation. I mean, it will not be in the formula sheet. Okay, there is no need to give it in the formula sheet. Then I have to give the equation by each and every question. That becomes ridiculous, right? So it is the Newton's second law. So n is equal to mg plus a. If you want, you can memorize it, no problem. But why do you have to memorize it? You can just work it out in your head, right? Even without writing. So n is equal to mg plus ma. Good. Now, n is what the scale read, not mg. Because how much you are pressing on the scale is what is n. So what the scale read is n. So that's why if you take a scale and stand on an elevator on top, keep the scale on the floor of the elevator and stand on it, and you watch it, it will not show your actual weight while it is moving. It will change. So now he is saying, my actual weight, this is the mg, and when I go in an elevator which is moving up but slowing down, what should happen to the n? Yeah, because a, if it is 0, it will be mg. If it is positive, it will be greater than mg. If it is negative, it will be less than. What do you mean by positive, negative? Just the direction. Yeah. Positive. No, wait. I'm talking about the acceleration on the velocity. A, direction is up. It doesn't mean elevator is going up. Okay. Pay attention. The direction of acceleration is up, mean it's a positive acceleration. If the direction of the acceleration is down, mean is a negative acceleration. Okay, now I'm going to put up a table here. I will write here the movement, move. And here I will put speed. Here I will put direction. Okay, and here I will write A acceleration direction, A direction. Here I will write n, the value of n. So the elevator can go up. I will ignore this guy. And the elevator can go down. No, up. Still keep it up. In both, it is going up. Why do I need two of them? Here the speed is increasing. Here the speed is decreasing. So the two scenarios. Elevator is going up, speed increasing. Elevator going up, speed decreasing. You can have two more, right? Elevator going down, elevator going down, increasing, decreasing. So there are four scenarios we can talk about. Each case is different. All four are different. So now tell me, elevator is going up, speed increasing. What is the direction of acceleration? Same as the motion of the elevator, same as the velocity. We learned this in your chapter 2. When you move with the increasing speed, acceleration is in the same direction as the velocity. If you move with the decreasing speed, so I go like this. I move this way, but I am decreasing speed. What is the acceleration direction? Opposite. All right. So elevator is moving up, that means the velocity is up. Speed is increasing, so A direction is up. Don't say positive, negative now, okay?
And the n is equal.
I will come there later, but let me finish with this, okay? All right. What about this? Is decreasing mean acceleration is in the opposite direction. Okay. Now come to this. Elevator is moving down, increasing, so same direction. Elevator is going down, decreasing, so opposite direction. Now I got the direction of the acceleration. So up direction mean acceleration is positive. Down direction mean acceleration is negative. Negative, then positive. So n here will be, because a positive acceleration greater than mg. Here,
This
negative direction, that means n is less than mg. Here it is again less than mg. Here, okay, right. Suppose the elevator stopped. What happened to the acceleration? Zero. Suppose the elevator is moving with, up with a constant velocity. What is the acceleration?
moving up, it will end.
Listen to me.
Constant velocity.
Yeah. Moving up with constant velocity. Acceleration is zero. Moving down with constant velocity. Zero. There's no difference. Whether you are moving up or down, if the velocity is constant, actually, you know, if the elevator is fully proof, soundproof, and there is no jerk, you wouldn't know whether it is moving up or moving down. There is no windows. There is no way of knowing whether it is moving up or moving down if it is moving with a constant velocity. There is no experiment which can show you whether you are moving up or moving down. Until you hit something or stop, right? As long as it's moving with a constant velocity. Right. So I hope it is clear. So let me move on. Number 7.
Can you back?
Yeah, sure.
What the answer?
Yeah, I don't want to tell everything. Okay, so what's the yellow one is the answer. Okay, let's look at it. 700. Okay, that is normal force, it is moving up. Slowing down means decreasing speed. So acceleration direction is opposite. That means down. So A is negative. So it will be less. So less than 700 knot. So N is less than mg. So N is what the scale read. So what the scale read is less than mg 700. Number 7. A disc-shaped object of mass 2 kg is sliding on a smooth horizontal surface. So this is some disc. This is going in the horizontal surface. There are only 2 horizontal forces acting on it. We don't even have worry about the z forces because they are balanced. It's only moving in this plane. So, they will balance and cancel each other. So you can say the net force is just F1 plus F2. So F1 is given. F2 is given, and the mass is given. You asked for the acceleration. What should you remember now? Newton's second law, which tells you net force is equal to mass into acceleration. Okay, not mg. All right. G is just some acceleration for this. Right. So A is equal to, we can do this question, it is, if you look at it, it's a very simple question. He is given the net force, well, separately F1 and F2, you add them, so the net force, and divide by the mass, you will get the acceleration. Right? I mean, why it looks difficult? Because these are vectors. And if you know how to do vector addition, you just do it like any other normal addition. There is nothing, that is the only complication, but that shouldn't make you feel scared. I mean, that's very easy. Let me show you. A is equal to, net force means F, all the force added as vectors. Then you substitute. What is F1? As a vector, 2, 4. What is F2? 4, 0. You use this angle bracket. So you know the first value is the x value, the second value is the y value. Divide by 2. Then now you treat it like you do any addition, but only complication is you add the x's separately and add the y's separately. It's a plus, right? Here, not minus, it's a plus. So 2 plus 4 is 6. And 4 plus 0 is 4. Yeah. Sorry, what did I say? 4. Divide by 2. Now this is a scalar. This should go and divide on each of them. X separately and the y separately. So you get 6 over 2 is 3. 4 over, there it is. We got the answer. See, we are dealing with x and y at the same time. This is a special case mathematically, but in practically, you have to do the separate fx equal to max like we did before, right? But if you give like vectors, then you answer both at the same time. You get the x component of the acceleration and the y component of the acceleration at once. Right, let's move on. Number 8. Again, chapter 4. So you have a box. Let me take the attendance, then I cannot pause this. That's a bit, this is Newton's second law. So something we saw before, but this time we don't have a friction. There's a normal force, is already the Weber diagram is given, there is an external force that is applied at an angle of 20. Question is find the normal force. So how do you do that? We don't have as vector, so you do it x direction equal to mass into acceleration in the x direction. In the y direction, Because a two-dimensional problem, we need both x and y. But the question is about the normal force, right? Normal force is in the y direction. So if you apply the, all right, so that's why I will keep it aside. I will use this, the net force in the y direction. So we have the normal force that is in the y direction plus n. Then we have the f, the y component is plus f sine theta. I'll substitute later, okay, just keep it. What about mg? Minus mg. So I covered the y, this left side of the equation equal mass multiplied by acceleration in the y direction. What's the acceleration? So what do I get? N is equal to f mg, some little bit of algebra, minus f sine theta. This is not a difficult algebra, so I will just do it. It's fine, right? Now you just substitute, get the answer. M is 30. Somebody do the calculation for me. And see, you get the right answer. F is equal to 100. And theta is equal to 20. You should get this answer. Please check. Okay. All right. Now this one, little change because you introduce the friction now. It's a rough incline, rough flow, not incline, level flow, horizontal surface. Now this time he is asking for the acceleration. Acceleration in the x direction. So we have to go for this one. Net force in the x direction equal to mass in the acceleration in the x direction. Also you have to remember now we have 4 forces, not 3 forces, 4 forces. I want to do this, okay? So net mean all the forces. So can I do this? I will say there's a force N, take the x component. I'm just a label, okay? I don't plus, because sum. And I take the force F, take the x component of that. And you take the force mg and take the x component of that. This is the left-hand side of the equation. And take the mg, oh, sorry, I did, friction. Take the x component of that equal to mass multiplied by acceleration. I didn't do anything, just, I'm going step by step. So take all the forces, only the x component, add them. Equal to mass multiplied by acceleration. There is an acceleration, it's not 0. That's the question, right, to find that acceleration. Now go to the next step. N is in the
normal.
It's y direction.
It's in the y direction. So,
Zero.
okay, plus f x component is f cosine theta. I'll put theta, I'll substitute later. And mg is also in the y direction. So it is 0. And friction force is in the x direction, but is in the negative, right? So I can doubt and we know everything. This is 0, 0 anyway. We know this. We know this. We know this. We know this. Only unknown is A. I don't want to do the algebra now. I will use my calculator.
Okay.
So I want all of you to know how to use the calculator properly. Okay. So can I? Right. This is my calculator. I will type everything in the calculator. Okay, 0 I don't have to type. F, how much is F? 100. 100. Multiply cosine of theta. Cosine, how much is that, theta? 20. Okay. Okay, right. I'm still here. Okay, that is done. Plus
0.
0, you don't have to write it, right? So let me, why bother? Minus, okay, put minus for the name. Minus, how much? 60. And equal sign. Here the equal sign. Oh, my calculator.
0.
Equal sign is alpha. Don't press this equal, right? The sign, equal sign. Okay, I got the equal. Equal to m. M is equal to 30. Multiply by a. A is the unknown, our x. So alpha, right parenthesis. Make sure, please learn this, okay? Learn this, how to use the calculator. It will save you time. You will make less mistake, provided you know how to use it, okay? Don't learn it just before the exam. You will be in bigger trouble, okay? Just practice. You know how to use your calculator, and that's it. What do you do now? Shift calc. Is this the answer? But this is not the answer, okay? Because this is what was in the calculator from previous calculation. You have to press this equal button. You should see this L minus R. That is, calculator is verifying the answer. By substituting L to the left hand side of the equation, the right hand of this equation, you should get there to be equal. So L minus R should be equal to 0. So he got the answer, 1.13. So that's the answer.
Okay, we can check for that.
Yeah, of course, calculator, will not give you the answer unless it is L minus. It is going through an algorithm, okay, programming. So it check answer, it has its own way of doing it. Yeah.
Why is the angle 0?
Angle is 0?
And
Yeah. See, N, how many forces are there? 4 forces are there. What is telling you? Take all the forces, they are x component of all the forces, and add them. That's what it's telling you, right? That equal to mass into acceleration in the x direction. Right, so n in the x direction. N is in the y direction. So it has no component in the x direction. N cosine 90. Cosine 90 is 0. So the x component of n is 0. F x component of f is f cosine theta. Mg, the x component mg is also 0 because it is in the y direction, negative y direction, but still in the y direction. So it is 0. F, x component is negative f because it is to the left. Our positive x direction is to the right.
what's the why there is f and f cosine theta in the shape?
Yeah, because actually the force is, this is the force, right?
Yeah.
The force has some value. It is making an angle of 20 degrees. So, you can, to make it things quick for us, we replace this one force by 2 forces. One is the x component, or y component, and one is the x component. So that will make it quick for us to do the Newton's second law. You asked me the question? So you asked me, right? You clear now? See, we have this force, F. F is the force. The force is F. And you take the x component and the y component of this force. So you, in place of F, we produce 2 forces. One is F cosine theta, this is the x component, and F sine theta, this is the y component.
So why we add one force here? The f cosine.
Yeah, because I only want the x component.
Oh, yeah, it's good.
Okay, right? I only want the x component. And there are many different ways of looking at it. At the end, it is the same. Because I want you to understand completely. That's why I'm doing all this. But, I can give you some shortcut, but if you do it without understanding, that's not good. You should have a whole understanding. This is the shortcut. This is what I know.
Oh.
This is the shortcut, and there is no other shortcut. If you think shortcut is memorizing the equation for each and every question, then you are not going to learn physics. Yeah.
I found it another way.
Okay. Yeah, sure. No, tell me what you are doing.
I put 30
Mhm.
with the gravity
Mhm.
minus 100,
Mhm.
sine 20,
Mhm.
and shift calc. Oh, sorry.
Yeah, you are just showing the equation we did. Are you going to remember the equation for each and every question?
Easy.
You're not getting it. So you are saying, I remember the equation for this question. So when a question like that comes, okay. What if I change the question? You're going to memorize the equation for that question also?
Correct or not?
It's not about, of course it is correct, because you memorize the equation for this question without understanding anything. Right? I'm not going to give the same question.
Okay.
I'm not going to give the. It's not about. I don't know. I don't know what to do. I want to cry. Number 10. Now you think I'm making it difficult for you? I know that's what you think. That's not my intention.
Just it's correct or not?
It is correct. Oh, you want one answer? Yes, it is correct. All right. You know what you did was what I did. What you are doing is this, right? I took so much trouble to explain it, and you are coming to me and telling 100 cosine theta is 20 minus this is what 60 equal to mass is 30 into A. You are showing me this equation and asking me is this correct or not? What can I say? Yes, of course it's correct. But how much trouble I took you to come here? It's not like you are going to memorize this equation for this question. Then I learned. No, you didn't learn anything. Okay. Number 10. Two blocks, A and B, with masses MA and MB are connected by light string, and it is kept like this. And another string is connected to the B. So this string will have the tension of T1. This string will have another tension T2. They are not going to be the same because two different strings. And they are pulled together. So both of them will have the same acceleration, not only in magnitude, also in direction. So exactly the same acceleration. So when that happens, we can do a trick. We can say this whole thing is one object with the one acceleration. Although it's a two-body problem, I can reduce it to a one-body problem and apply the Newton's second law by saying this. The net force of the system as just one object with a mass of A plus B equal to MA plus MB, the total mass, multiplied by the acceleration of the total mass. We can do this. We cannot do it with the active thing, okay, the one pulley, because one is going up, one is going down. Same acceleration, but the direction is different. Okay. We cannot do that, as a system. There is a ways to do that, but it is not exactly correct. So here you can do that because the same magnitude, same direction. So now I can apply the equation. What is the question? Find the acceleration. Let's say hope we can do it. Can we? The forces are only in the, I'm going to do it in the x direction, okay? X direction. So let me take my.
How we know from the question is the x direction or y direction?
Yeah, when you ask for the acceleration, yeah, always acceleration in the, choose the x-axis along the acceleration, right? So, I mean, obviously you want to do it. Yeah, yeah, you look, if the question is find the acceleration, you already chosen the x-axis along the acceleration, so naturally you need the x-axis equation, x direction. Okay, so I needed the red pen. See, T1 on A to the right. This is also T1 on B to the left. If you consider them as a system, there's a T1 to the right and T to the left. They will cancel in the x direction. I want to apply the equation in the x direction. So the net force will be only this force, only T2. So T2 is for the system, okay, A plus and A and B together. T2 is the only force in the x-axis. There are, of course, vertical forces. It doesn't come into the x equation, equal to total mass ma plus mb multiplied by acceleration. The question is to find the acceleration. You know this. But T2 is not given. He is only giving us T1. So this equation has two unknowns. Yeah. Are you going to give up? No. We can apply the equation on A only. Only A.
The same acceleration would be, right?
Yes. So we can use A to find the acceleration. And the beauty with the A is on A there is only T1 acting. T2 is not acting on A.
Yes.
T2 is acting on the B. So again you write the equation for A. So the only force will be T1 on A, and the mass is mass of A, which is given, acceleration. This will solve the problem. T1 is given 14, divide by MA is 7, equal. Okay, right. It's good, yeah. So shall I now look at B and see what kind of equation I get from B? It's not needed for this question, but just I want to continue.
He said that acceleration, yes?
Yeah, now I want to apply the Newton. Yeah, same acceleration. Yes, yes, yes. I want to apply the Newton's second law on D. What are the forces on D in the x direction? T2 is plus, T1 is also there, but in the opposite direction. Equal to m is the mass of mb and acceleration. I mean, what's the problem with this? We have the T2. So that's why it's not that useful. The MA, applying that on MA is useful for us to have. Yeah, T2. Once you have the T1 from here, A from here, you put the A there, you can find T2. So I can change this question and I'll ask you to find T2. But it will be long. You have to find the A first, then go there. You have to use both equations.
Let's try.
Right. Okay, let's do the question number 11. I will stop unless you want me to continue.
This one.
This one, okay, the last one. Right. Yeah, let's do this. Yeah. We have two more classes, so we will do more questions, inshallah. I'll not do the lab, okay? We can postpone the lab to the week after. Here, tension, find the tension. And if you draw the free body diagram for this guy, M1G down, T up. If you draw the free body diagram for this guy, the same tension, right? T and M2G down. I already done the free body diagram for both of them separately. So question is to find the tension, and if you go to the M2, we have a problem because the value of M2 is not given. But M1 is given. So naturally, the best thing is to apply the equation to M1. Net force in the y direction, because in x direction there are no forces anyway. So that is to answer your question. Now, how do I know? Somebody asked me, how do I know? He asked me whether to use the y direction, x direction. So here, It's moving in the y direction, so that is where the acceleration is. So in the x direction, you'll not get anything. You'll get 0 equal to 0, right? Net on M1. So T is up, so I'll put positive, minus M1G equal to M1. So we have to be very careful to put the subscript because there are two masses. They don't get confused later. You don't know which one you are referring to. So always put the subscript there. Into A. A is given, is the magnitude of the A, right? So you have to be careful when you substitute. This is should be put with the correct sign. When you substitute, well, A stands for the magnitude. So if you want here itself, because A, you know, it's a magnitude. So I need the sign. So I should put minus A. I hope it is clear to you. Because A is the magnitude. I will only put for A, I will put 3. I will not put minus 3 or plus 3. Therefore, I put a minus because it is going, acceleration, not is going down. Don't say it is going down. Acceleration is down. Okay, it is going with increasing speed. And that's it, right? The rest is just calculated, isn't it? The rest is calculated, right? Because the only unknown is T. There is no T1, T2. Why didn't I put T1, T2? Because it's just one string. So either side of the string, it is the same tension, one string. Okay? So I didn't put, there's no need to put T1. Same tension. So there are some assumptions, there's no friction in the pulley, and you can say it's the same tension. So I can use the calculator. So let me, I don't want to do what you call the algebra. So I'll take my calculator. T is the unknown. Yeah, so I'll call it X minus M1G. M1 is 11 kilogram multiplied by 9.8 and then equal minus 11 multiplied by 3. We should give the answer. You don't have to do any algebra. Shift, calc. This is, you know, it's... Huh? Okay. Let me do this, then I'll go back again, okay? So let me do it again. That's the answer, but let me do it again. Right. So let's do it again. T is how much?
Unknown.
Unknown. So I'll call it X. Minus 11. Let me do this because, you know, I just want to be very clear now. I'll put the bracket, although it is not needed. 11 multiplied by G is a magnitude, okay? G is the magnitude, so 9.8. Equal, right, now you ask me, okay, why did I put then 11? I will not put, okay? M1 is a magnitude, I'll put 11. Multiply by, I better do this now. You're happy now?
Yes.
Isn't it the same thing? Yeah, I skipped the step, okay? So. Yeah, you have to put the bracket. Otherwise, if you don't put the bracket, it will be 11 minus 3. It is completely wrong. That's why I put the negative in the front, to avoid that mistake only. But if you don't want to make a mistake, go like this. Okay, yeah.
What about the answer?
Yeah, okay, I'm coming to that. Now, why didn't I use the M2? Because the value of M2 is not given. So it is not going to answer me the question. Yeah.
What?
Huh?
Which one?
No mode for that. You just type the equation in the calculator and shift calc, you know. No mode here, okay. I hope you understood this, right?
Give me the direction of acceleration, yes?
Yes. I mean, no. I mean, sometimes he may not. He will say M1 is greater than M2. Then you have to figure out which is going to go up and which is going to go down. M2 is less than M1. So M2 will be going up, M1 will be going down. So you have to read the question and get it right. Yeah. We help you too much. Okay. Right. I will stop the recording. I will stop now.